February 23rd, 2019. So, yesterday the wire came. I got what I could afford. This is 18 aug. I got 100 feet for 30 bucks or so, I think. I could have gotten thicker wire, but it got incredibly much more expensive as I looked at thicker wire. And I thought about it, and these linear actuators aren't drawing all that much power, and the power that they are drawing is not continuous duty. It's maybe 20 or 25 seconds max before a 5-minute delay, so the duty cycle is very low. So I think it'll be okay for now. I probably will upgrade it later on. But for now, I got the wire and I got the relays. I'll show you those. Okay, so this is a relay that's unopened, and this is an opened one. I got the relay and the socket, I should mention, so you got the nice screw terminals, so you can hook things up without having to actually solder. So that'll be really nice for wiring. You can see right on the top of the relay. Now you can see on top of the relay. Wiring schematic right on board. These are the LY2N-J. As I was looking around for relays, I found that these are pretty popular. So I figure if one fails, I can easily replace it, and cheaply. I think I got both of these for like $10.24 or something like that. So they're certainly cheap enough. They're 12 volt DC. They're capable of 10 amps at 250 volts AC or 10 amps at 28 volts DC. So they far exceed the usage of these linear actuators, which I installed the hardware in a previous video. And so tonight, now that I have both the parts, I'm going to wire these in and adjust the code and make some changes here. We'll take a look at the relay setup currently, and then I'll show you when we're done. I guess we'll take you over there. So hold on. So here we are over at ye old master switch panel. This is the 8 relay board, and that's tagged in off the Raspberry Pi, and those are all controlled by GPIO high-low settings through Python for the code that I'm running. The top 2 relays with orange wires coming out, those are the up and down for the old linear actuators, 110 volt AC. Those were rigged in through a couple of plugins that went in to the inverter, which is still connected to power. So I'm going to change how that operates. And then that third relay down from the top was the inverter trip relay. That was the one that actually turned the inverter on and off, on for when we needed power and off when we didn't. 110 AC power, I should be clear on that. So these 2 top relays are coming out with the existing wires. We're going to run in clean, nice DC wires for the linear actuators. Those will break out over to here somewhere. I'm probably going to take this old relay out, and I'll probably mount these 2 relays for the up and down linear actuators, like right here. Also, these have a green LED indicator on them, so you know when they're firing as well. So should be very easy to diagnose if there's an issue, which would be nice as well. Alright, so that's the general basic plan. And I'll let you know how I do. I guess real quick, I'll show you, I didn't show you this before, the relays are separate from the socket, so you can replace a relay that simple. Hard to do this with one hand, but there you go. Pop an old one out, pop a new one in, done. No wiring, no messing around. I probably get a couple of backups of these so I have them in stock, so if one fails, it should be okay. I think these are rated at 1,000,000 cycles and 100,000 guaranteed reliability to 99% or something like that. Anyway, I think these will do the job. Okay, so just a quick testing hookup. I've looked at the schematic on top here. says 7 and 8 are supposed to be the coil. Sorry for the focus. 7 and 8 are these two. So I just hooked them to a test wire, and I hooked the ground side on, and I'm tapping the positive side. And you can see we're firing the primary coil on the relay. So relay works, and shouldn't be too hard to wire up from here out. Alright, so I've stripped all the 110 AC wire feeds out of there. You can still see the remnants hanging there and here. We'll finish removing those later. So the two upper relays are now empty and open, and I made up a little pigtail right there to plug in. We're going to pick up this open breaker number 3 on the lower left side here, right there, that little guy. I wouldn't worry about that little guy. And we're going to run that as power to these breakers, and also to the other breakers, which, as I said, will be mounted here. So, progressing along. After pulling those, I just want to make sure I didn't screw up any sensors or anything. So I ran another database insertion script just as a test. Everything went fine, so that's good. Onward. The heat pump is on at the moment, but you may have heard that rain starting to pick up, rain or sleet starting to pick up in that last video, and it just opened up now. I just thought I would share it quick. Coming down out there. Nice and toasty in here, 75. Snack break, of course. I know things look kind of rough here, but we got some nice cherry tomatoes popping out. And I had one a couple days ago. It was nice and sweet. A couple more. So I just picked this one. Snack time. Oh man. February 23rd. And it tastes like summer. Two relays in, some of the wiring in. Got the jump overs and power up to those relays. See that? Farmacy sees network so fast you don't need a loading bar. Part 1. Testing. You can see that light went on, and that light went on. We're getting there. Alrighty. Well, it took a little bit of figuring to get the relay figured out. I got some chicken scratchings and brain thickens here on the page. This is the thing you should really focus on for this wiring. Okay, and then I basically went off of that diagram and converted to wiring over here. I'll explain that in a minute. And we're basically just using one of these relays as a trigger for the top vent for now. Wanted to get one vent figured out, and you can see that's on, and the panel is going up, and this is just a test script, so it'll go up for whatever I set the time at. I don't recall the number of seconds. And then as soon as that time is done, it'll come back down. I'm not gauging off of temperature sensors at the moment. This is just for testing. There she goes, coming back down. I'm not even sure if it's set to a long enough time to fully close, but I just kind of wanted to give the quick demonstration. We got it working, that feels good. Looks like that 18 gauge wire is plenty to do the job. Closed, and it'll kick back up again in a sec here. You'll hear the relays click. she goes. A little hard on the initial open, but seems to handle it okay. You can see the force it puts on those beams. Those are going to be shored up in the spring or summer when I get around to fixing a few things in the greenhouse here. Anyway, we're going to have reliable venting again, and I guess we should take a look at wattage consumption now. Okay, so we are now going to test wattage consumption running. I just cleared all the relays, running only the script to raise and lower the upper vent, and I'll zoom in on the wattage here. Sorry for the camera fluctuations. And I'll start the script. Pulling about 8 watts steady initially. Interesting, it goes to almost 36 there, but then it goes off steady to 25-ish and drops. I'll have to look at what the time is. I think we're about 20 seconds from all the way closed to all the way open. That might be what I have the script set at, I'm not sure. Okay, so it looks like about 20 steady once it gets rolling for up, and about 15 steady down. And of course that's with the pi at a resident 8 watts underneath. I'll stop the script so it'll finish and close. We'll go back to pi only power. Yeah, there we go. Sitting about 7.5, 8.5 watts in that range. Okay, so that's a little assessment of the power. I'll do a few calculations and throw some text up here. Okay, final test product. Now ready for code updates. We're wired. I got 2 different scripts running. One for the upper vent, one for the lower vent. Just testing opening and closing them. I'll give you a shot of the relays here. Let you see all of them. You can see that's the upper vent, and that's going up by the green light and red light being on. And now it's coming down. And then the lower vent will start going up in a minute. There you go, there's the lower vent. Let you see that opening. And so the total stroke time is 25 seconds. At least that's the on time right now for up. And so you can see it switches right back. I'm not sure we're opening all the way. I'm probably going to increase that to 30 seconds. So hang on a sec. And I'm going to do one vent at a time so as not to confuse you so much. Because this other vent is going up at the moment. Definitely cooling off in here quick. It's a good thing it's not too cold out. Alright, so kill that one. And we'll kill this one. Okay, I guess we'll show you the low one first by itself. Note, we're still 7.4 to 8.6 watts base wattage. I'll start the test now. A little less power drawn because we're not pushing as much straight up on the vent. Alright, that's doing good. Show you the vent here. Opening and closing. That's good. Watch it lock down. If it gets to that before it hits the trip again. And lock out. and trip up again. There we go. See both the relays light up on the right. Up she goes. So that's working good. So that's 2 vents wired and installed and tested. Now I just got to update the code for them. I think I'll do a separate video on the code. After I figure it out, because we're not going to do incremental raising anymore. We're just going to be opening or closing vents when necessary, because we can't turn the power supply off without adding another relay connection, and right now I'm not messing with that. Alright, that's it. We'll stop that, and we'll run the other vent quick. See the relay kick in. See it go to about 36 or 40 watts on startup. And it goes to like 25 and it scales down to like 20. Going up. You can see heat going out of the greenhouse. A little bit of steam coming off. Damp and misty and cold out tonight. So there you go. Upper and lower both work. Now we just got to write the code in for thermal read and adjust. And so just real quick, I'll show you what we did here. We brought in a control from the relay, which is the black wire coming in here, black with a red stripe. Comes in and hits the number 7 pin. The number 8 pin is hooked to ground, I believe. No, number 7 pin has ground. The number 8 pin is where the relay comes in from this relay. It is the normally open circuit that gets picked and closed. That sends power down to trip this relay. This relay, when it trips, we'll say this is for left-hand relays for upper vent, right-hand relays for lower vent for reference. And then this relay, when it trips, when it's in the default state, it's getting positive and negative coming through to positive and negative here. And then when it's flipped on and tripped on, these two crossover wires cross the power over to invert it, so you actually get positive on the black and negative on the red, and so that way you're reversing direction. So one trips it to go up, and the default state is relay off, and that brings it down. So your default is always to bring your panels and vents down and close them so you don't have a problem, and then when the temperature gets too high, you go to the other state and open. So both vents are wired the same way, just one is for the upper and one is for the lower. And again, the reason that's important is because you want to be able to let heat out, and when it's still too cold out to let cold air in, you don't want to freeze your plants. So you open the upper vent to vent heat, and then as the outside temperature exceeds a certain temperature, usually 55, that's when you start to open the inlet vent. Of course, it depends on the crop you're growing and what you're doing. But anyway, so I think that concludes the upgrade for DC Linear Actuators with relays. They're running on a Raspberry Pi. This is a Pi 3B Plus. And of course, this is all solar powered with a battery and 100-watt solar panel, a charge controller, and we got the dual monitor meters here. One monitors panel power produced, and one monitors battery power. Those are probably not accurate at this point. They need a reset. I've done some tinkering. Anyway, I think that covers everything. If you have any questions or comments, please do so down below. Thanks for watching the Farmacy Seeds Network, and look forward to the next part where I will go over the code that I'm using to control these sensors and how it works. Thanks for watching the Farmacy Seeds Network. Please like, subscribe, and share.